In October 2017, something slipped quietly into our solar system, passed close to our own planet, and was gone again, almost before we knew it had ever been here. We caught it on its way out, already racing back toward the darkness it came from. And the more we looked, the stranger it became. It was the first object we had ever confirmed to come from beyond our sun, a visitor from another star entirely. But that alone is not what made it remarkable. What made it remarkable was the way it moved, leaving the solar system with a push that gravity alone could not explain, behaving in a way that seemed to bend the rules of physics. So strange was its behavior that a handful of serious scientists were willing to reach for an explanation as extraordinary as alien technology. What was it? What did it do that shouldn't have been possible? And is it out there alone? Join me today as we trace the story of our first known interstellar visitor. The story begins on the 19th of October 2017 at the Haleakala Observatory in Hawaii, home to the Pan-STARRS survey, a network of telescopes built to scan the sky for moving objects like near-Earth asteroids, some of which could one day pose a threat to us. It was here that researcher Robert Werrick picked out a faint point of light moving against the stars. By the time he spotted it, the object had already made its closest approach to the Sun 40 days earlier. We hadn't seen it coming. We had only caught it leaving, and it had come close. When it was first detected, the object was only about 0.22 astronomical units from Earth, around 85 times the distance to the Moon. It had already swept past us at roughly 0.15 astronomical units. To put that in perspective, the Sun sits a full astronomical unit away, about 93 million miles. In the vast scale of the solar system, this was a very close flyby indeed. But close is not the same as dangerous, and this object was never in any danger of hitting us. Things do pass nearer. In 2004, a small asteroid skimmed by at just a tenth of the distance to the Moon. There have been closer calls still. In 1972, witnesses across Western North America watched a huge fireball streak overhead, heard a double crack of sonic booms, and then saw the fireball climb back out of the atmosphere and return to space. It had simply come in at too shallow an angle to land. And of course, objects do sometimes strike us squarely, as the Chelyabinsk fireball of 2013 or the Great Barringer crater in Arizona remind us. But our visitor was never going to be one of those. It passed close, said nothing, and kept moving. The danger was never the interesting part. Everything else about it, however, broke the rules. When the object was first found, no one knew quite what to call it. It was classed initially as a comet, the natural assumption for something falling in from the outer dark. But comets announce themselves. As they near the Sun, their ices warm and boil away, wrapping them in a hazy cloud of gas and dust called a coma, and trailing the long, bright tail we associate with them. This object showed nothing of the sort, so it was quietly reclassified as an asteroid instead, a bare lump of rock and metal. And then it became clear it was neither. The giveaway was in its path. As astronomers pinned down its orbit, they realized it was moving far too fast and along too strange an angle for the Sun to ever hold on to it. Its trajectory was hyperbolic, an open curve rather than a closed loop, the mark of something passing through rather than orbiting. It had not fallen in from our own outer solar system. It had come from somewhere else entirely, almost certainly from another star system altogether. This was something genuinely new. Every comet and asteroid we had ever catalogued belonged to our Sun. Here, for the first time, was a confirmed piece of another star drifting through our neighborhood. The International Astronomical Union found itself with no existing category that fit, and so it created one. The letter I for interstellar, and the object was formally designated 1I 2017 U1. It needed a name too. Astronomers settled on Oumuamua, a Hawaiian word meaning, roughly, first distant messenger. Though in some circles another name circulated, borrowed from Arthur C. Clarke's novel Rendezvous with Rama, in which humanity encounters a mysterious craft from beyond the solar system. Which name was more fitting, Scout or Starship, was, as we'll see, the very question that came to haunt the discussion. For a while, there remained a slim possibility that Oumuamua wasn't truly interstellar at all, that something in the outer reaches of our own system had flung it onto that hyperbolic path from our distant Oort cloud. But the physics of its motion now appears to rule that out. It really did come from beyond our sun. Which raises the obvious question: if Oumuamua came from another star, then which one? Here, frustratingly, the trail goes cold. Oumuamua arrived from the direction of Vega, one of the brightest stars in our night sky, sitting in the constellation Lyra. It would be tidy if that were the answer. But the timing doesn't work. Vega wasn't in that part of the sky when Oumuamua would have set out, so as inviting as it looks, it isn't the home we're searching for. The deeper problem is that tracing the object back is very nearly impossible. Imagine trying to reconstruct a game of billiards played 100 years ago, knowing only the path of the final shot. Every collision before it has been erased, every angle lost. Too little information survives to rebuild the game. Oumuamua is the same. By the time it reached us, whatever sequence of gravitational nudges set it on its course had long since faded from the record. Astronomers have tried anyway. In one study, Corinne Baylor-Jones and colleagues reconstructed a few of the object's recent close encounters, at least recent in a geological sense. One was with a red dwarf about 1 million years ago, another with a Sun-like G-type star some 3.8 million years ago. The authors themselves caution that none of these are particularly good candidates. None of the systems are even known to have planets, so Oumuamua most likely just drifted through them rather than being launched from within. A binary star system might fit its speed better, the gravitational dance of two stars being well suited to flinging objects outward, but no good binary candidate has turned up along its path. And there is a hard limit to how far back we can ever look. In separate work, Q Zhang examined the problem directly, concluding that even with data from missions like Gaia, backtracking any interstellar object beyond a few tens of millions of years is likely beyond us. Oumuamua may have circled the galaxy many times over, for so long that its origin is simply ancient history, gone for good. It isn't always hopeless, though. The nearby young star, Beta Pictoris, has an enormous debris disk that flings material outward, and it's known to have comets. If one were ever ejected our way, we might actually pin down where it came from. And then there are the stranger possibilities. In one paper, Roman Rafikov raised the idea that an object like Oumuamua could be born of something far more violent, torn from a rocky world by the tidal forces of a white dwarf, or hurled out in the death throes of a supernova. If its origin was a mystery, its appearance only deepened it. The first hint that something was wrong came from its light. As Oumuamua moved through the solar system, it brightened and dimmed dramatically, cycling roughly once every 8 hours. The most natural reading of that flickering was an extreme shape, something long and thin, tumbling end over end, throwing back a lot of light when it turned side on, and very little when it pointed toward us. A cigar, in other words. Though, as Karen Meach and her colleagues noted in their study of the object, it could just as easily have been the opposite. A flattened disk, something more like a pancake spinning through space. Either way, nothing in our own solar system looks quite like it. Then there was the question of what it actually was. The obvious first guess, a comet, ran straight into trouble. A comet passing this close to the Sun should have come alive, its ices warming and venting, throwing off dust and wrapping itself in a coma and tail. Oumuamua did none of this, and there was no good excuse for it, because a comet's ices should comfortably survive billions of years, crossing the empty dark between stars, arriving with plenty left to burn. Stranger still, when astronomers studied its surface through spectroscopy, it looked oddly familiar, much like the bodies we already know in our own solar system, some of which happen to be rich in organic compounds. That's a tantalizing detail in itself. Comets are among the leading suspects for delivering the raw chemistry of life to the early Earth, and it's possible that wandering objects like this one help seed the ingredients of life across the galaxy, perhaps even life itself. So if not a comet, then an asteroid. That brings its own difficulty. Asteroids are thought to be considerably rarer than comets out in the galaxy, based on how we believe star systems form. And once again, there's that shape, which fits no asteroid we've ever seen. Oumuamua, it seemed, refused to sit neatly in any box we had, which left the door open to something far rarer. Perhaps a shard of a shattered world, a fragment of a planet torn apart, the kind of object we might not stumble across again for thousands of years. And then, Oumuamua did something it simply shouldn't have. In June of 2018, Marco Micheli and colleagues published a finding that changed the whole character of the story. As the object left the inner solar system, it didn't slow down the way it should have. The Sun's gravity should have been gently reining it in, dragging on it as it climbed away. Instead, Oumuamua left a little too fast, as though something were giving it a faint, persistent push. Accelerating is almost too strong a word. It's more that it departed less reluctantly than the laws of gravity allowed. There was an obvious, boring explanation waiting in the wings. This is exactly what comets do. As their ices boil off on the sunward side, the escaping gas acts like a small natural thruster, nudging the comet along faster than gravity alone can account for. Perhaps Oumuamua was a comet after all, just a shy one. But we're back to the same wall. No outgassing was ever seen. No coma, no tail, no dust. And even venting from invisible water ice should have lifted detectable grains of dust off the surface. There was nothing. The contradiction ran deeper still. Later work by Rafikov pointed out that any outgassing strong enough to give the object this push should have spun it up, twisting its rotation until a body this fragile tore itself apart. Yet Oumuamua kept tumbling along, perfectly intact. Then came the strangest measurement of all. In November of 2018, David Trilling and colleagues trained the Spitzer Space Telescope on the object, hunting for it in infrared. They found nothing, and that nothing was loud because they should have seen it. The only way for the object to be invisible to Spitzer was for it to be very small, on the order of just hundreds of meters across. But small and faint don't go together here. To have been spotted at all in the first place, something that tiny had to be extraordinarily reflective, far shinier than we'd expect. To be thorough, SETI teams even listened to Oumuamua for any whisper of radio emissions. They heard only silence, small, mirror-bright, accelerating with no visible cause, and utterly quiet. It was at this point that the strangest hypothesis of all stopped sounding quite so impossible. The case for the extraordinary was assembled most forcefully by Avi Loeb of Harvard, who laid out 6 strange attributes of this object. First, by his reckoning, we should never have found it at all. Earlier work suggested interstellar asteroids ought to be too scarce for us to simply stumble across one, which means whatever produced Oumuamua may be far more common than anything in our own system. Second, it sat in an unusual frame of reference, the local standard of rest, the average motion of the stars around us, which is precisely where you would hide an object if you wanted to disguise where it came from. Third, it must have left its home with an unusually high velocity, hinting at a rare and violent ejection. Fourth, the shape, with a length perhaps 5 to 10 times its width, when the most extreme objects in our solar system reach only about 3. Fifth, it was tiny yet bright. And sixth, that unexplained acceleration. From there, the boldest claim followed. Together with Shmuel Bialy, Loeb argued that sunlight itself could provide the push, the gentle pressure of solar radiation, but only if Oumuamua were astonishingly thin, less than a millimeter thick. And a wafer-thin sheet catching sunlight to sail between the stars is, well, exactly what we might build ourselves. A light sail, an artificial craft. There is even a thread of logic standing for it. Earth's oxygen-rich atmosphere has been broadcasting the signature of life to the galaxy for a very long time, long enough, in principle, for someone out there to have noticed and aimed a probe our way. But the case against is heavier. What are the odds of catching an alien probe in the brief moment it crosses our solar system, unless such probes pass through constantly? Its tumbling fits a sail poorly. It travels strangely slowly for built technology, and its spectrum looks thoroughly natural, like a reddish object weathered by radiation over the ages, with accumulated dust just as able to explain its shine. For my part, I lean where the evidence leans. Oumuamua is most likely a natural object shaped by an extraordinary history, but it would be a poor scientist who slammed the door entirely. So, where does that leave us? With a handful of competing stories and not quite enough evidence to choose between them. Oumuamua might be a dead comet hiding its activity, or a shard of a shattered world, or a sliver of alien technology drifting between the stars, or something we haven't yet thought to imagine. Each theory explains some of the strangeness and stumbles on the rest. That uncertainty isn't a failure, it's simply where the frontier currently sits. The good news is that the dark may not stay dark for long. A new generation of survey telescopes is coming online, built to sweep the whole sky again and again, and they should soon tell us whether objects like Oumuamua are passing through all the time, or whether this really was a once-in-a-civilization encounter. If many appear, then Oumuamua was simply the first of a crowd. If almost none do, it becomes the most extraordinary object we have ever seen, and chasing it down, difficult but not impossible, suddenly becomes urgent. Either way, our first messenger has already done something remarkable. It arrived as a question, and it left us with even better ones. And perhaps that's the real gift of it. The universe handed us something that didn't fit, and in refusing to be explained, it reminded us how much is still out there waiting. The itch of that curiosity is the whole reason we keep looking up. The only certain thing is this: unless we're willing to chase the mystery, we will never know what was really passing through.